In 2022, ChatGPT, a generative artificial intelligence chatbot, was released. High school students everywhere rejoiced, high school teachers everywhere despaired, and the rest of the world was thrown into general chaos. Today, more than a year later, we see AI doing everything from creating art to investing in the stock market to writing computer programs. Between the AI chefs and the AI surgeons and the AI robot supreme future overlords, one might ask, is there really anything that computers can't do? Introducing the halting problem. This is H, a machine that can do something very special. H takes a program as input, reads it, and tells you if the code will run forever or if it will halt. For example, this program here contains an infinite loop, so H outputs no, since it doesn't halt. Here, this program is guaranteed to stop running, so H outputs yes, since it halts. Now, let's introduce another machine called N. N only accepts two inputs, yes or no. If N receives no as an input, it will output yes and halt. But if N receives yes as an input, it will enter an infinite loop and never halt. Now, let's link H and N together in a machine called X. The output of H, either yes or no, is the input to N. So what happens if we pass X to itself? Will X halt? Well, that's exactly what H is supposed to tell us. Say H predicts that X does not halt, outputting no. But N will receive no and immediately output yes and halt. So H said that X would not halt, but X halted. H was wrong. If H predicts yes, saying that X will halt, N will take that yes as input and respond by looping forever. So X will not halt, but H said that X would halt. H was wrong again. So H contradicts itself. It's not always right, which means that a machine that can predict if a given program will halt or not cannot exist. Proof and problem were discovered by Alan Turing in 1936, and they still have incredibly important implications today. For example, many problems in practical computer science can be shown to just be the halting problem in disguise. Furthermore, if the halting problem were solvable, we'd be able to prove so many mathematical theorems, such as Goldbach's conjecture or Kolmogorov complexity. The halting problem is also the key to proving Gödel's incompleteness theorem on the limits of what is provable in formal mathematics. So the halting problem shows us something kind of revelational, which is that there exist theoretical limits on computation that even if we had infinite time and infinite memory, we still wouldn't be able to overcome. So hey, at the end of the day, computers might take all our jobs and conquer the entire world, but at least they'll never be able to solve the halting problem.